Okay, this is lesson 40 homework questions. We're going to start with number 1. Lesson 40, number 1. This is the one where the dog is on the rope. Let me find the right page here. Okay, a dog tied by a rope to a pole moves through an angle of 35 degrees along a circular arc. How far does the dog move if the rope is 30 feet in length? Now, the first thing you have to think about is this, let's see, I'm on a pen. Let's go with blue. Okay. Is the rope 30 feet? Oh, why not? This thing. Okay. If the rope is 30 feet, is that the radius? Yes. So the dog's tied here to the tree or the post and out to here, so that is your radius. So your radius is 30 feet. So how far does he move? All right, we remember that the definition of a radian angle is the ratio of the arc length to the radius. So when theta is in radians, theta equals L over R. So how do I change 35 degrees to radians? I take 35 degrees, I'm going to multiply it with pi radians is 180 degrees. That's my conversion. 180 goes downstairs because I want degrees to cancel. So 35 pi divided by 180 gives me a radian angle. Theta equals 0.61087. 0.61087. So what I'm trying to find is how far does the dog move? So the question is, what is the length? So theta times the radius equals the arc length. Theta 0.61087 times the whole length of the rope, because that's the radius, right? Because the dog's going to go around the tree like this. The whole radius is 30 equals the arc length, so times 30, second answer times 30 gives me 18.33 feet. 18.33 feet. All right, lesson 40, 18.33 feet is correct. So the idea here is a radian angle is the ratio of the length divided by the radius. The length divided by the radius. My conversion of degrees right here, converting degrees to radians is to multiply by pi over 180. 180 degrees is pi radians. So that's 40, number 1. All right, let's look at lesson 40, number 14. Here we go. Okay, this time I've got my angle given to me in radians. But I'm more comfortable, and you're more comfortable, working in degrees. So the first thing I want to do is take this 2 pi over 3 radians, 2/3 pi radians, and change it to degrees. This time I want degrees upstairs and pi downstairs. So this will give me an answer in degrees. And so 2/3 of 180, I know this is 120, why do I push it in there, is 120 degrees. 120 degrees. So this, instead of being the sine of 2 pi over 3, is really just the sine of 120 degrees times the cosine, again, of 120 degrees minus, don't mess with that, minus 4 pi over 3. Again, my conversion is 180 degrees is pi radians. Pi's cancel. 4/3 pi, 4/3 times 180 should be 240. I do know these things. 240 degrees. So this is the sine of 240 degrees. Okay? So now, where's 120 degrees? Let me change colors. Now we're back to something we've already know how to do, right? Now we're back to 120 degrees. Well, all the way over to the negative x would be 180. So I'm going to come up here and I'm going to stop 60 degrees short. That would be 120 degrees. Now opposite the 60 is square root of 3. The hypotenuse is always 2. That makes this one 30. Opposite the 30 is 1. In this quadrant, get rid of that, that's bugging me. In this quadrant, x is negative, y is positive, and we know the hypotenuse is always positive. Now 240 degrees is 60 degrees more than 180, right? 180 plus 60 gives me 240. So that's my 240 degree angle. Opposite the 60 is square root of 3. The hypotenuse is always 2, so that makes this one 30. Opposite the 30 is the 1. In this quadrant, x is negative and y is negative, and the hypotenuse, of course, is always positive. So what is sine? SOHCAHTOA. Here we go. SOHCAHTOA. Sine is opposite over hypotenuse. So for this angle, it's going to be square root of 3 over 2 times the cosine, negative 1 over 2. Cosine is adjacent over hypotenuse, so this is my adjacent over the hypotenuse. So that's the sine times the cosine minus the sine of this angle. Sine is opposite over hypotenuse, so that's be negative square root of 3 over 2. So minus a negative becomes plus a positive. So this is negative square root of 3 over 4 plus, I'm going to get this one over 4 by multiplying it by 2 over 2. So negative square root of 3 over 4 plus 2 square root of 3 over 4 leaves me with only one positive square root of 3 over 4. So negative 1 square root of 3 over 4 plus 2 square roots of 3. So negative 1 plus 2 gives me a positive 1 square root of 3 over 4. So this is number 40, or lesson 40. Number 14, yay, I got it right. Positive square root of 3 over 4. Okay, number 16. Lesson 40, number 16. Same idea. First thing I'm going to do is I'm going to change these radians to degrees. All right, tired. Let's go, that is blue. Let's go with purple. We haven't used any purple yet. All right. Negative 19 pi over 6 times 180 degrees is pi radians. So 19, let me do negative 19 divided by 6 times 180, because I'm just going to let pi's cancel, times 180 equals negative 570. Well, negative 570, that's negative 360 plus something else. So if I add 360, that gives me negative 210. So negative 210 degrees. Well, here's negative 90, negative 180. So negative 210 is right here. Right? So this is the sine of negative 210 degrees. 210, here's negative 90, negative 180, negative 210. So that makes this angle 30. Let me get rid of my marks here. That makes this angle in there 30. Well, if this is 30, opposite the 30 is the 1, the hypotenuse is always 2, that makes the other one square root of 3. In this quadrant, x is negative, y is positive. Alright, so 13 pi over 6, let's see what that one is. 13 pi over 6 times 180 over pi. 180 degrees is pi radians. So the pi's cancel. 13 divided by 6 times 180. It's going to be 390. 90, we recognize that as going 360 plus 30 more. So this is equivalent to 30 degrees. So this is the sine of 30 degrees. Right? 30 degrees is right here. Opposite the 30 is the 1. The hypotenuse is always 2. Makes the other side square root of 3. In this quadrant, x is positive and y is positive. Okay, so along comes the Indian princess to help us solve this. So the sine is the opposite over the hypotenuse. Now look at this one. The opposite is 1, the hypotenuse is 2. So that's 1/2 plus the sine of 30, opposite over hypotenuse, 1/2, I don't need a calculator, 1/2 plus 1/2 is 1. So less than 40, number 16 is 1. And that is the correct answer. Okay, last one from the homework questions. Lesson 40, number 23. Okay. This one says the graph of the function f of x equals 1 over x is centered at the origin. So this is my function 1 over x. The graph on the right is the same graph translated, that just means moved, so that it is now centered at 3, 0. So instead of being centered, what's a good color for this one? Blue, I guess. Let's go with blue. So instead of being centered here at 0, 0, I'm now centered here at 3, 0. At 3, 0. So what am I doing? I'm shifting the whole graph 3 right. When I shift the whole graph 3 right, instead of y equals 1 over x, I get y equals 1 over x minus 3. Y equals 1 over x minus 3. Let's check that. All right, here, when it was 1, 1 over 1 is 1. When I shift 1 3 right, where do I end up at? 4. So when I put in a 4, I should get out a 1, do I? Y equals 1 over 4 minus 3, which is 1 over 1. So when I shift to the right or the left, I'm shifting in the x direction. I subtract the shift. When I shift 3 right, I subtract 3 from the x. I subtract 3 from the x. Okay, here's a little extra bonus here for you. What if I want to shift 1 over x? Remember my original function up here in the pink was y equals 1 over x. Alright, I want to take that function, and with this blue, I want to shift it 3 right and 2 down. Well, 3 right is positive 3 in the x, 2 down is negative 2 in the y. Alright, so instead of saying y, I say y minus a negative 2. I subtract the y shift from the y equals 1 over x minus 3. You subtract the x shift from the x. So minus a negative becomes a plus. Solving for y, I'll get y equals 1 over x minus 3 plus 2. Or I'm sorry, eraser, minus 2, because I bring it to the other side. Pen. Minus 2. Okay, let's check it. Alright, when I put in a 4, well, I don't know if I can check it. 0, 0 puts me there. Yeah, I don't know if I can check it, but quickly. But when I move it 3 right, whatever I'm doing the x direction, I subtract from the x. So instead of 1 over x, it's 1 over x minus 3. When I move it 2 down, I take my y and I subtract a negative 2 from it. So y minus negative 2 equals 1 over x minus 3, and then solve the whole thing for y by just subtracting 2 from both sides. Okay, that should be all the homework questions that we had because of the power outage. You can go ahead and send me more if you want. This isn't that hard to do eventually once I figure it out. Okay, bye.